Hello and welcome to Teachopedia. In today's video, we will be covering Numpy, which is a Python library. We will be seeing some basic functions of Numpy that can be used to easily interpret this library. So without wasting any time, let's get started. So Numpy is a numerical Python library which consists of multi-dimensional array objects. We use Numpy for applying mathematical and logical operations that can be easily performed on arrays or multi-dimensional arrays. Tools like or libraries like Pandas are built on top of Numpy array. So let's code something. So first we will import this library using import numpy as np. Then we will be creating an array using np.array. In this we are creating a one dimensional array. So how do we do that? We will be using square brackets, and in that we will apply or give some input values. So here I am giving 4 numbers and it will create an array of that numbers. So in that return we will get a one dimensional array which contain these 4 values. Moving on, we are now creating 2-dimensional arrays named as B and C, and in that 2-dimensional array we have rows and column. So here I am creating a 3 by 4 means 3 rows and 4 columns arrays B and C, and in that we are giving some input values. So using np.array we can use 2 times square brackets and then give rows and column values. So here I am declaring 3 rows 371 starting from 371 and then creating 4 columns after that. So if I print this, I will get two-dimensional arrays or 2D arrays in this return. So that's how you can easily create one-dimensional array and two-dimensional array using NumPy. So now we are now seeing some attributes of an array like size or shape. So how do we find that? We use n-dimensional or ndim for finding out the dimension of an array. Same goes for shape. We use dot shape for finding the shape, which will give us or return the shape of that array, and in the end dot size will give the overall size of that array. So here I am finding out the array A, which was one-dimensional array, and we are finding its dimension, shape and size. So if I run this, I will get a dimension of array which is 1 because it has a 1D array, and the shape will give us 4 column and 1 row. Since 1 is not in the written down here, so that means that it's a 1 row, and the size of an array is 4. Now I will repeat that same case and same thing for B variable, which was 2D array. So here in return I am getting a dimension of 2, shape of an array which has 3 rows and 4 columns, and a size of 4 multiplied by 3, which is 12, and there are 12 values, 4 4 4, 12 values in this B array. Same can be repeated for C 2D array as well. So now we can apply some operations on this NumPy array. We can easily multiply a constant with an array, and in that we will get another array which was multiplied with that number. So here I am multiplying C, which was a 2D array, and multiplying it with 3, and how it will work, like if I just print C here, it will first multiply 8 multiplied by 3, which give us 24. Same goes for 1, it will give 3. Same goes for 5, it will give 15. So for each item or each value it will multiply by 3, and in that return we will get a 2D array which will be multiplied by 3. So here I am getting a result after multiplying by 3 which was a constant number. Same goes for adding. We can add two different 2D arrays, and in here we are adding B and C, so both were 2D arrays, and in that return we will get its summed array in 2D format. Same goes for apply multiplication operation. So we could multiply two 2D arrays, and in the return we will get a multiplied 2D array. We can also square for each value by using 2 times static, and it will square for each value. So if I just print B here and do this square for each item, it will give a 3 times 3 means 9, 5 times 5 means 24, 25, sorry, and 2 times 2, which is 4. So for each item or value, it is giving a square of that value. Or then we can also apply some logical operations. We can easily check to see which values of B are greater than values of C. So if I just use a logical operation greater than between these two 2D arrays, in that return we will get a 2D array, but in the value will be returned as false and true, which means that false means that B is not greater than C, and true means B is greater than C. So if I just print these two 2D arrays here, we can easily see that 3 is not greater than 8, so it gives us false. 5 is greater than 1, sorry, so it gives us true. Same goes for other values. Now we can also find a particular item like a minimum in that 2D array. So to do that, we can easily get or use .min and just pass our array, and it will return the minimum number in that 2D array. For each column we can also find minimum. So to do that, we have to pass a argument or parameter called axis, and in that we have to define it 0, which means focus on column. So for each column it will give its minimum value. So for this column it will give 1, this column 5, this column 2, and then at the end we will get 4. So in that return we are getting 4 values, which means 4 minimum column values individually. Same goes for row. We have to pass axis is equal to 1, and now it will focus on rows. So in the first row 2 was the minimum, second 6, and then the third 1. So in that return we are getting 3 values, 2, 6, 1. Same apply for max as well. We can easily find the maximum in the 2D array using np.max. So now we will be using array indexing and try to access single elements in arrays. So if you are not familiar with indexing is like a number which is starting from 0, 1, 2, 3, and we use index to extract some values from an array. So here we have an array called A which have some values, and we want to print some or extract some values like 9. So what we do is we put a 0 in square brackets, and it will give 9 as an output. So we use 0 as an index. Same goes for -1. It will give the last value of that array, that is -3. In a multidimensional array, items can be accessed using a comma separated tuple of indices, like we have to define row and column as well. So here we have a 2D array, and now we have to access the first element, and what we do is we use 0, 0 to access that. For accessing the third row we use 2 because it starts from 0, so 0, 1, 2, and then 2, -1 will give 7, which is the last value of that 2D array. We can also update that value by using the same thing like we use for printing, but rather than now we will replace that with a new value that is 12. So it will update that value as well. So now let's try to learn how to create copies of an array. So dot copy is a function which is typically used to create a copy of array. We use copies, or we make copies to create a new, so to create a sub copy so that the actual ones doesn't change. So if we are replacing some values, we do this in a copy of array. So here I'm creating a copy and then updating a single value with a new value in that copy. Another function which is quite powerful is reshape. What reshape is do is like it's the most flexible way of doing, like if you want to put numbers 1 to 9 in a 3 by 3 grid, means a 2D array, you can do using reshape. So here I am arranging 1 to 10, between 1 to 10 numbers I am reshaping that numbers into a 3 by 3 2D array. So in return I am getting a 2D array which contains values between 1 to 10. Another common reshaping pattern is the conversion of a one-dimensional array into a two-dimensional raw column matrix. This can be done with reshape method very easily. As you can see, we can easily convert and create a new 2D array. So it's quite a good function. Another function is concatenation. We use concatenation to merge two different arrays, but remember it should have same rows and columns. So all of the preceding routines worked on single arrays. It's also possible to combine multiple arrays into one, and to conversely split a single array into multiple arrays. So we use np.concatenate to merge two arrays. So here I am creating two arrays xy, and using np.concatenate I am merging those two arrays. Same goes for adding another array in this concatenation. We can merge, we are now merging three arrays using .concatenate. We can also do that with 2D array, and using the same pattern we just pass 2D array two times, and using .concatenate we are getting a new merge array of these two 2D arrays. So these were the helpful functions which we quite easily use and get the basic understanding of how NumPy works: concatenation, reshaping, creating copies, accessing elements through indexes, apply some logical and mathematical functions on arrays, how to create arrays, how to determine the size and dimensions and shape of an array. So these were the functions which we saw today. I hope you found this NumPy tutorial useful. If you have any queries, do let me know. Until next time, thank you so much.